God, this sucks. Okay. Hi, my name is Amy, and welcome to Ask the Expert. Just a little bit about me before we get in this first in a 3, maybe 5-part series of physics problems. My background is in actually dietetics. I'm a registered dietitian, and my main specialty is in mathematics as it pertains to that area. However, I really like helping people of all different ages and areas who struggle with math problems. And that includes dabbling a little bit of physics. But believe it or not, the skills that you need in order to solve this series of basic physics problems don't just apply to future problems in that engineers or mathematicians need to know. It actually applies to other fields, including being a dietitian / nutritionist. So that being said, let's move on to get to the heart of the problem here. Okay, and just give me a second, get a drink of water, whatever you need to do. We're gonna flip over to the screen share and go from there. All right, so here's the original problem or series of problems. And one major reason why I really wanted to tackle this series of problems is because it's whoever wrote this series of problems, they knew what they were doing. It was very calculated. What I mean is the professor, the instructor had a very specific or 1 or 2 very specific objectives in mind. I don't want to give away the hint, and I don't pretend to read minds, but I believe they wanted the student to understand how important it is to do a certain thing and hopefully give them an aha moment. And this does it beautifully. I'll try to kind of emphasize that as I go through these problems. So enough being said, enough of that. The overall theme of all these videos is basically giving you kind of a systematic approach to solving rate and velocity problems in physics. But you can use this model in a lot of areas of math. And what do I mean by that? Well, I always think, okay, when you have an English class, you write an outline before you write a paper. And kind of gives you a template about how to do it. And there's different kinds of types of writing, right? If you're writing an essay, if you're writing an argumentative, trying to write something that's a letter, etc., etc. You have a template that kind of helps you kind of organize your ideas and systematically attack it. And that also kind of gives you confidence. It also kind of keeps you from being overwhelmed, and you just become more efficient at what you do. So that's kind of the idea here. So hopefully that'll make a little bit more sense is as we go along here. And from the real basic to starting to get a little bit more advanced in problems number 2 and 3. But okay, so with enough ado, let's get to the meat and potatoes of problem number 1. So that's the first problem I circled here. So we have this problem, okay? First thing I always, it sounds kind of, maybe redundant or kind of silly maybe sometimes, but is to read the problem and ask yourself, what is it that it's asking me to do? Particularly also if you get lost in a problem, you're overwhelmed. And sometimes it just kind of helps you refocus to remember, what was it that I was supposed to do? So let's think about that as we read this problem. So it says, if a car moves at a constant rate of 5 meters per second, what distance does it reach in 45 seconds? Okay. Another thing is if you need to, might help you draw a picture. This one, maybe it's not, maybe it's needed as much, but still would be good to have it to get into. The other thing is step 2, and that can go before or after the picture drawing, it just depends, is to kind of highlight some key words in the problem, and then kind of write them down, and then attempt to translate them in key language, just to kind of give you, a starting point, and kind of write down what is given. So in this problem, I highlighted constant rate, and I highlighted 5 meters per second, and I highlighted or underlined the word distance and 45 seconds. So I write all those things down, and then I attempt to kind of make some sense out of them. So constant rate. Okay, what does constant rate? Hint, hint. This is what I'm getting at as far as one of the objectives. Whoever wrote this series of problems wants you to really understand well. Really think about what constant rate means. Well, translation, constant. Constant means never changing, right? So the rate and speed stays the same over the same period over time, okay? So I wrote that down. What's this 5 meters per second? Well, isn't that, it came right after a constant rate of, so that's what the actually specific constant rate is that we're speaking of. It's the 5 meters per second. So it's always at a constant rate of 5 meters per second. And that's our rate, our constant rate. And then we have distance. Distance, okay. We don't have a specific distance. Oh, that must be what we're trying to find. And then one thing I forgot to write down here is that 45 seconds, okay? What's the significance? That looks like a time. Now, you write these things down, and if it doesn't ring a bell by now, get used to it. You will. You do enough of these problems. Bingo. Looks like a rate times time equals distance problem. If you don't know that by now, memorize this equation. It's not going away. You're going to see it in algebra. You're going to see your ACT math and science. You're going to see it in physics, chemistry, just about everywhere. Okay? It's not going away anytime soon. So it's a fundamental physics equation that you must need to be able to recognize and know. Okay. So that being said, once I know the information above, I'm just going to restate that what each of those variables means. Distance means d equals distance, r equals rate, t equals time. And then we're going to, again, specify what each of those specific things are in the problem that are given. Wait, distance is what we're going to be trying to find, right? We're going to try to find how far the distance goes within 45 seconds, okay? So that's what we got to find. Now, our rate, as we said, was our constant rate, 5 meters per second. And our time is 45 seconds. So what we do, we basically plug and chug. We use that equation, and we plug in the variables. So we have distance, rate, and time. Now, before I move any further, this is kind of this problem. There's no need for this, but another thing you're going to need to check in future problems is make sure that your units are the same. There's another term for that. It's not coming to me right now, but if we're dealing with seconds, we need to have everything in seconds. We can't have a combination of seconds and minutes per se. Then we would have to convert the minutes to seconds or seconds to minutes. Okay, I think you know what I mean. But let's take a look at that. So if we have minutes per second and we have seconds, okay? So by default, we're probably going to want to do basically, did I say minutes per second? I'm sorry. Miles, did I say meters? I don't want to mix you up here. Just make sure I got the right thing. Meters. Meters is our unit. Okay. Just make sure you get that right. Our distance is in meters. Let's see here. I'm going to write this right there because that's kind of confusing. I don't want to mislead you. But our rate is in meters per second, and our distance is going to be in meters, right? So we chug and plug, and we have our rate, we have our time, and what you're going to do is when you chug and plug that is you're going to find out, I don't know if that's a universal term, that used to be what my math teachers used to call it in high school, but it's very catchy. So anyway, if I cross out the seconds and I do seconds, they cancel out, and that leaves me with 5 meters times 45. So my distance that I get is a distance equals 5 meters times 45, and I get 225 meters. Now, it may not be so obvious with this one, but you always want to think about whether something makes sense, okay? Now, it may, if it was in miles per hour, it might be a little bit easier, or in just straight miles. We're doing with meters, but if nothing else, just kind of read it like a sentence and think about, you know, I don't want to say grammatically, but just logically, does it sound right? Okay, so we have something, it was 5 meters per second. Okay, that means we went 5 meters in 1 second. Okay, and it's saying that we want to know how far it went in 45 seconds. So if we take that 5, we're timesing it by 45 seconds, and that gives me an answer of 225. Does that sound right? Hopefully you said yes, and that's the answer. So that's a very basic concept. Now, you'll kind of see how this can get a lot more complicated, and how really organizing your and systematically approaching these problems becomes more important, can really help you out when you get to a little bit more complicated problems, such as in 2 and 3. So this is a snapshot. Looking forward to part 2. You have a lot more definitions to think about. You have a lot more variables. So it might help you to write a chart, and you may even need to draw a graph to kind of, or a picture to help you kind of keep things straight. Okay, so that's what's up in part 2 and 3 of our series here. And again, I might have to break the last video down into even more parts because there's so much going on. I mean, not a ton, but enough where I want to break it into different videos. So that's enough for now, and I'll look forward to seeing you next time in this video series of Ask the Expert related to a systematic approach to solving basic rate and velocity problems in physics. Thank you very much, and see you soon.